Okay, here are the Unit 1 big ideas. So in topic 1.1, we talked about classifying if a relation is a function or not a function. And the big idea is that every input, x, has only one output, f of x or y. Now, this is going to be the good answer that you give, right? When the question asks you to explain or you're on the Regents, this is your good answer. However, we do have tricks that we use in order to classify whether something is a function or not, okay? And these are our tricks. These are not our good answers. These are just our tricks to identify whether something is a function or not given the form that it's in. So we have the graph test, the vertical line test. And this is where you can't touch f of x more than once. We have in a mapping, ordered pairs, that's like a list of coordinates, or a table, you can't have any repeating inputs. This is when we say if x repeats, it's not a function. That is not your answer, though. If the question ever asks you to explain why something is a function or not a function, you always go back to this nice explanation here, okay? So let's put a warning down here. Not a good test answer. This guy and this guy. All right. So topic 1.2, we often refer to a relation as anything that's not a function. I mean, functions are also in the category of relations, but if you're trying to talk about something that's not a function, you would say it's just a relation. Okay, so in a relation, we have a domain and we have a range. These both come from an xy coordinate point on the graph. Okay, the domain encompasses the variable x. On the graph, you can find the domain along the x-axis. And in a function form, the domain can be thought of as the input. The range, on the other hand, is going to be y, or sometimes you see it written as f of x. You can find it along the graph as the y-axis. And in a function, you can think about it as the output. When you're describing the domain and range in a graph, you can always put the word to in between the two values that you are describing. All right, topic 1.3. This was graphing day 1. And if anything I say during this review video is not ringing a bell, you can always go back to the day that I'm referring to, right? 1.3, 1.4, 1.5, and you could reread those notes. Okay, so in graphing day 1, we learned that you substitute input values into a function. And those values are the x values. You can solve using a function for each y or f of x, right? You can substitute in an x value and get out a y output. You need to plot the points that you get from there as an xy. And then you have to graph and label that bad boy. All right. Topic 1.4 was graphing day 2. And when we're doing graphing day 2, we went over a lot of TI Inspire or calculator tricks. And if I were you, I'd follow along on my calculator with these. So to get to the table, you do Control T. To get the grid lines, so it's easy to count or view special points, you can go to Menu, 2, 6, 3. And then there's more calculator tricks located on the notes, page 12. And you should definitely review those before the exam. So topic 1.5, that was graphing day 3. And we talked about the input values, which are the domain. They're all X values that the graph spans. And you can find them by looking on the X axis. The domain always goes from left to right. And whenever we graph something over the domain or over the interval, you would have the number that it starts at going up to the number that it ends at, and you would use special brackets or parentheses depending on whether you're including that number or not including that number in the domain. If you're a little fuzzy on this, you can always also just use the word to, or you can use inequalities where X values are sandwiched in between the start of the domain and the end of the domain. All right, cool. Topic 1.6 was function notation, your favorite. So in function notation, you always want to remember that f of x equals y, right? This is the structure for function notation. This shows you where everything goes. X's are always in the parentheses. Y's are always to the right of the equal sign. Okay? In a graph, you will see function notation like this. In a table, you will see function notation represented like this. And in an equation, you will see function notation represented like this. Here we go. On the graph, let's say you had something that looks like this. F of 3 equals 17. This is the X value. This is the Y value. And you can find him on the X axis. You can find him on the Y axis. In a table, you would have your X's and your Y's listed like this. Okay? And let's say you had a 3 here and you had a 15 here. This would be written in function notation as f of 3 equals 15. Okay. Let's see. In the equation, you would have f of x is equal to x plus 1. The x is your input. The y is your output. If you were trying to find f of 3, everywhere you see an x, you would pull out that x, put in a 3, and then you would evaluate. F of 3 is equal to 4. Okay, so those are the 3 different ways you're going to see function notation represented on the exam. Topic 1.7, domain. Are all x values in the function. You can find them by reading horizontally along the x-axis from left to right. Okay, you can either write it as an interval or an inequality. For example, let's say you had something like this. That would be from 0 to 4, including both items. Your inequality would look like this. Let's say you had something that looked like this, 0 to 4, not including 4. Your inequality would look like this. Let's say you had something like this. 0 to infinity. It would look like this. 0 is less than x, which is less than infinity. Okay. Remember, when you're graphing over a domain, your graph has endpoints. It does not have arrows when graphed over a domain. If it's not specified, you would have arrows on the end. Okay, topic 1.8 was range. We read the range vertically. We find it along the y-axis, and you can think of it as low, high, y. Okay? When you're looking for it on the graph, let's say you had something that looked like this. The range would span from here and go all the way up to infinity. Okay? And you would also write the range the exact same way you would write a domain. You can use interval notation, inequality notation, or if you're a little shaky on the topic, you can always just write the word 2. Topic 1.9 was real life math. That was connecting our mathematical models to real life. Big takeaways from that day: you need to make sure you answer the question. If the question asks you to find x, your answer better look like x equals. Make sure to provide math evidence. Restate the question when you're writing your answers. Use units. And if you're explaining something in the context of the problem, you need to mention both variables and their units. Write the point first. Explain what each variable stands for, then write your sentence. When time equals 5, the height of the ball is 20 feet in the air. Something like that. Topic 1.10, 1.11, key features of functions. All right, this is a heavy hitter here. Key features of functions. Okay, the x-intercept is where y equals 0, and the point will look like some number and then a 0. Okay? The y-intercept is where x equals 0, and the point will look like 0, comma, some number. The turning point is where the function changes direction. And you can think about finding these by looking for the peaks and the valleys along the function. Whoa, that was weird. An increasing variable or an interval of increase. The y values are going up. And you can remember Bertram is walking uphill. And then decreasing intervals. The y values are going down. And Bertram is walking downhill. Okay, and you write intervals of increase and decrease as domains. Use the x's to describe where they occur. The maximums and the minimums, they are two different types of turning points. The maximum is at the top of a hill. The minimum is at the bottom of a valley. And when describing the maximum or the minimum of a function, you talk about its y value. You write it as y equals, okay? And you find these in the range. So think about intervals of increase and decrease as belonging in the domain, right? We use the domain to describe where the intervals of increase and decrease are occurring. Whoa, hey. Okay. And then we use the range to describe where maximums and minimums are occurring. Okay. 1.12 was transformations, your favorite. So we have the parent function f of x. If we are thinking about transforming f of x and we have x minus some number, that's going to be a transformation to the right. If we are talking about f of x plus some number, that's going to be a transformation to the left. Why? Because the inside lies, right? That transformation is grouped inside parentheses with the x, so it's going to be the opposite of what you think. When we have f of x plus some number and the number is all by itself outside, that is going to be a shift up. When we have f of x minus some number and the number is all by itself outside of the parentheses, that's going to be a shift down. And these signs don't lie. These are what you think. Positive is up, negative is down. Those make sense. If you have a number out front of f of x and it's a whole number, I want you to think about that guy as getting narrower. And an example could be 3x squared. There's a 3 out front. If you have a fraction out front, the new function is getting wider. And an example could be 1/3 x squared. And if you have a negative out front, the function flips over the x-axis. And you can think about that as a reflection. Whoa, reflection. All right, cool. 1.13, that's going to be average rate of change, which can be thought of as just plain old slope. Okay? So we sometimes refer to the change in y, the change in the distance of y, as delta y. And then delta x is going to be the change in x. And we can calculate the slope as the change in y over the change in x. Sometimes you see it as rise over run. Okay? So when you're calculating average rate of change, a lot of times you're going to be given a graph. And the problem is going to ask you to calculate the rate of change over the interval from some value to some other value, -2 to 5. You're going to locate those points on the graph. Let's say it's -2, 3, and then 5, 4, right? You want to calculate the average rate of change over that interval. You take those 2 points and you put them in a table. and then you calculate the slope. You find the change in y, which would be +1. You find the change in x, which would be +7, okay? And the average rate of change, or the slope of the line that passes through those 2 points, is going to be the change in y over the change in x, and that would be 1/7. Okay? I think that's about it.